Hello guys, welcome to another section of Miss Math. I hope you guys are doing good. Yeah, I hope so. I hope everything's going well with you guys. Yeah. This integral problem here, looking at the nature of it, you might think it's very difficult. Yeah, even assuming this one and this one is not there and it's like tangent inverse integral of tangent inverse of 2x or tangent inverse of u, we have to integrate that. Even that one alone is not all that maybe easy to deal with. But here is the case, tangent inverse is being multiplied by another thing, that is 1 plus 4x squared. Yeah, you see, it won't be all that easy. Yeah, if you look at the nature of it, what will comes into your mind is, this problem, how am I going to do it? Might be very difficult, but it's not all that difficult. It might be, but it's not all that difficult because um, the moment you figure out the approach to use, you could see that after figuring out and you start applying the approach, you see that, oh, it's not that difficult as I was thinking. What will make this problem difficult is maybe when you find it difficult to come out with the approach what to use. So first of all, I want you to know that this problem is not all that difficult. It's very simple, and you see the moment when we start working. I mean, when we have choose the approach that we are going to use and we have started applying, you can see that, oh, it's very well simple. Okay, so to erase that idea of this problem being difficult or blah or to make you feel okay that this problem is not all that difficult, why don't we get started so that you know what I'm saying. Okay, so let's write our solution first. Now let's bring this integral down here. Good. As I said, the moment you figure out the approach to use, this problem here is not all that difficult as you may be all thinking. But what approach at all are we going to use? Um, what approach? Well, here in this video, I'm going to use what? Use substitution what approach. But I don't know if other approaches can work out for you. I don't know, you can try other approach, and if you do and it work out, you can let me know. But here we are going to use the use substitution approach. We are going to use the use substitution what approach. But how is it going to be used? Are we going to let u be equal to this or that? Well, we are going to let u be equal to, integrating tangent inverse of 2x won't be all that easy for us. So we are going to first let u be equal to this 2x, and when we do that, then probably we will differentiate to find what is going to replace what dx. But when you do that, still we haven't got anything what is going to replace this one in the what u word. So what will you do? Maybe you just think of making x the subject from the equation, which is u is equal to 2x, and then x will give you what? U over 2. If you do that, you are not wrong. It's good. Probably that's what yeah, that's what you will do it. Okay, so when you do that, and then in the u word, you just replace what? X with what? U. So when you do that, just going to get this place to be what? 4 times to bracket u over 2 all squared, and then they just compute. Yeah, if you do that, you are not wrong. That one is also got okay. But what I'm going to do here is that here this side we are having what? 2x, and then here we are having what? 4x squared. 4x squared. So here, since this one is a perfect number and this one is also what? Being squared, what I'm going to do is that I'm going to find a way of rewriting 4x squared to get something like what? 2x, so that at the end of the day, when I do the substitution, this side and this side will be affected at what? Once, so that we will not waste another time of making x the subject and substitute it into what? The integral again. Okay, so we are just going to rewrite this one to get this, and to do that, 4 is the same as what? 2 times 2 is what? 4, and then x is the same as what? X times x. So meaning we can write this 4x squared as what? 2x raised to the power 2. 2x raised to the power what? 2. Okay, so let's do that before we do the substitution approach. Good. Okay, this is what I was talking about. When we rewrite this one, you could see that this side and this side has now become what? The same. So you could see that the moment we do the substitution, this side and this side will be affected at once, because this and this are what? Is what? The same, or what? Are what? The same. Okay. So now I think we can do a substitution, and then when we do, we got nothing to worry of. Nothing that we should be thinking of what is going to replace this one in the u word. The way that we have written this one, the moment we do the substitution, this side and this side will be affected what? At once. Okay, so let's do our substitution. So substitution. All right, u is equal to 2x, and then here, let's differentiate. So when we differentiate this, we're gonna get du is equal to 2x. Du is equal to 2 dx. 2 dx. 2 dx. Now let's find what is going to replace dx. So you're gonna get dx equal to 1 over 2 du. 1 over 2 du. Alright. Now in the u we replace dx with this one, and then in the same u word we replace 2x with what? U. Okay, so now let's replace them. You see, this side and this side has been what? Affected. Good. So here, what we are going to do here is that I've told you, don't open the bracket, because when you do that, just what? Making the problem what? More difficult. We are just what? Wasting time, because at the end of the day, maybe you have to factorize it back. So just leave it as it is. So here we're just going to write this 1 over 2 at the back here, and then we focus on what is here. Okay, so let's do that. Good. Now what are you going to do? Here we are going to do another substitution. But first, how did we know that when we do another substitution it's going to help us? Well, this one is tangent inverse of what? U. And then here we are having 1 plus u squared. And there is what? 1 on top here. assuming this one is not there, this tangent inverse of u is not there, and we are to integrate 1 over 1 plus u squared, the answer to that integral will just be tangent inverse of what? U. The answer to that one will just be what? Tangent inverse of what? U. So if we want to get this one back, what do you have to do? To reverse the integral, you do what? You differentiate. So when you differentiate tangent inverse of u, probably you're just going to get 1 over 1 plus u squared. Okay, so this means that when we substitute this one for another variable and then differentiate, we are going to get something of this nature, and then we make it the subject. We make maybe the u or whatever, the blah blah, the subject. At the end of the day, we can be able to eliminate something from here, or we can eliminate what? This one, without finding what is going to replace it. Okay, so why don't we try that one? So let's do another substitution. So here we're going to let m be equal to this one. Okay, so m is equal to tangent inverse of u. What are you going to do? Let's differentiate. So when you differentiate, you're just going to get dm is equal to 1 over 1 plus u squared du. Good. The derivative of this one is what? Just this. And this one here is, assuming this one is not there, is just this one what? Here. Okay. So we are moving to another word, that is what? The m word. And here we are having dm is equal to 1 over 1 plus u squared du. Let's find what is going to replace du. So let's make du the subject. It is going to multiply both sides by 1 plus u squared. And when you do that, this side you're going to get 1 plus u squared dm. And then this side you're going to get this one times this. And this and that, what is being multiplied by will go away to be left with du. So actually you're going to get du is equal to 1 plus u squared dm. 1 plus u squared dm. Okay, so now let's replace them. Good. So after putting it into the integral, this is what we have gotten. 1 plus u squared over 1 plus u squared times what? M. This m is representing what? Tangent inverse of what? U. And then this dm is representing what? This du is representing what? The whole of this. But when we bring this one here, actually they're going to multiply. So actually it will be 1 over the whole of this times this one. And definitely we are going to get 1 plus u squared over 1 plus u squared times what? M. You see? So here, what are we going to do? Very simple. This and this are the same. So this will cancel out with this one to be left with what? M. You see? Good. So let's continue. So this will cancel out with this one and to be left with what? M. Good. So 1 over m. Now when you integrate 1 over m, what are you going to get? Well, you're going to get 1 over 2 natural log absolute value of what? M. Make sure you take the absolute value, because if you don't take it, your answer is not correct. You may get some bonus mark, but the actual mark you know because given, because integral of 1 over x or 1 over any variable, at the end of the day, the answer will take what? Absolute what? Value. So here we're just going to get 1 over 2 natural log of absolute value of what? M. Now we are done with the integral. You see the substitution that we did. You remember I said the moment you figure out the approach, you can see that what is very, very, very simple to what solve. You see, The moment after applying the new substitution, you see our problem wasn't all that difficult for us to also it was more easily than what we thought it could be. So that is the answer to this integral question here. But this is the answer in the M world. What is the answer in the U world? Well, we know that M is equal to tangent inverse of what? U. M is equal to tangent inverse of U. So the answer in the U world is going to be 1 over 2 natural log tangent inverse of what? U. Okay? Good. That is the answer in the in the U world. But what is the answer in what? The X world. Yeah, probably we have to, get back to what X world. This is not a definite integral whereby we have to do everything in this particular world or this world, because the moment we do the substitution, we also have to find what is going to replace the limit that will be what given. Okay, so there is the answer in the U world, and what is the answer in the what X world? U is equal to what? 2x. 2x. So let's replace this one with this, and that will be the answer in the X world. All right. So the answer in the X world is what? 1 over 2 natural log of absolute value of tangent inverse of 2x. So the answer to that integral we started solving is what? 1 over 2 natural log of absolute value of tangent inverse of 2x. So let's end it. Therefore, integral this is equal to 1 over 2 natural log uh, absolute value of tangent inverse of 2x plus c, meaning we are what? Done with everything. Okay, so guys, so you see that what I said initially was true. This problem wasn't all that difficult that as we were thinking, or as we were what assuming. Yeah, you see, it wasn't what that difficult. The only what will make it difficult is when you find it difficult to come up with the approach. The moment you know the approach to use, you see that, oh, it's not all that difficult as I was thinking. Because after that we did a substitution, we realized that a whole of this one can be taken away with what? The substitution. And if a whole of this one can be taken away, the rest is what? Very simple for us to what? Solve. So you see. Alright. So alright, that's it guys. Please, if you like this video, kindly give it a thumbs up, subscribe and comment. Thanks for watching.